This is Khalil Nassar with the Rokroot online debug training series. This is Concepts Prioritized Thread Queue. This module picks up where Module 2 leaves off and gives insight into the mechanism that drives state change in the operating system. The outermost level of state granularity is best understood when we consider the basic mechanism of the NT scheduler, the prioritized thread queue. The thread is the operating system's commodity of scheduling. This is the logical entity in the operating system that is allowed to execute CPU instructions. Each thread logically belongs to a process structure. The process structure is used to define the thread's world, namely where its memory exists. The memory space definition for a process, and hence all its threads, is defined by the directory base for that process. Looking at a thread structure as output by the bang thread kernel debugger command, we see its priority and the owning process. Looking at the process structure as output by the bang process kernel debugger command, we see the directory base from which all virtual memory is derived for the threads owned by this process. The .context command also gives the directory base, as does the CR3 CPU register. Here's a conceptual representation of the prioritized thread queue. The thread on the top of the queue is the next thread that will be allowed to execute in the system. It's on top of the queue because it has the combination of the highest thread priority out of all the threads in the system, and it has been waiting the longest for execution time. Note that priority trumps wait time. It will be allowed to execute for a short amount of time, which could amount to several hundred instructions. Once its execution time interval, known as a quantum, has expired, this thread is put on the bottom of the queue, and the next thread on top of the queue becomes current for its own quantum. This is a simplified explanation for conceptual learning. This is a subject we will come back to often for kernel debugging and driver development, as manipulation of this queue is what makes the modern operating system perform. When the operating system pulls the next thread off the top of the queue, the outermost level of state granularity, the process address space, may or may not be the same as the previous thread that was executing. So when the operating system initially accesses memory for the currently running thread, he does it via the directory base of the thread's owning process. In conclusion, the operating system virtualizes a computer's hardware with the concept of the thread. A thread, or execution context, is allowed access to the computer's resources for a brief amount of time that is governed by the prioritized thread queue and an execution timer. In future studies, as we expand on this subject, we will see that the prioritized thread queue is manipulated by synchronous and asynchronous events in the system to keep things running efficiently and smoothly. Thanks for studying with Module 4, Prioritized Thread Queue.